Okay, section 8.1 is the Pythagorean theorem and its converse. So I'm assuming you've heard the Pythagorean theorem at some point in your math career. So to remind you, it only applies if you have a right triangle. And so you're going to square both legs, add those two squares together, and then set it equal to the square of the hypotenuse. So A and B are representing the legs, and then C is representing your hypotenuse. So that's where they get the A squared plus B squared equals C squared. So we're just going to apply that theorem here first. The first question is asking, what is the length of the hypotenuse of this triangle? And then do the side lengths form a Pythagorean triple? So we would want to plug in these numbers into the a squared plus b squared equals c squared formula. So I would plug in 20 as a and 21 as b, and then I don't know c, so I left it as that. You could switch these around, so it doesn't matter which one you use as a or b as long as you put them in for a or b as the legs. Then I would go ahead and square them. So 20 squared is 400, 21 squared is 441. I would add those two together and get 841. And then to undo a squared, I want to do the square root. So I would do the square root of 841, and it comes out nice and even as 29. So then my three numbers, 20, 21, and 29, this is a Pythagorean triple if it falls suit into the Pythagorean theorem. So every time you get a number that squares a squared plus b squared equals c squared, those three numbers together are called a Pythagorean triple. So yes, this is a Pythagorean triple because they fit into the Pythagorean theorem. Alright, so let's take a look at another problem where you have to find a missing leg or hypotenuse. So it says, what is the value of x? And then it's showing you that x is on a leg, you have 8 as a leg, and then 20 as your hypotenuse. So I just went ahead and labeled them as a, b, and c. Again, it does not matter which is a or b for 8 and x, but you must use 20 as your c value. So I went ahead and plugged those in, and I got x squared plus 8 squared equals 20 squared. Then I simplified. I got 8 squared to be 64, 20 squared to be 400. I would subtract 64 from 400 and get 336. To undo this square, I want to do the square root. So I find what the square root of 336 is. When I type that into my calculator, it's a long, messy decimal. So this is why you are practicing simplifying those radicals, because it wants my answer in simplest radical form. So we would need to find the highest, or a, perfect square that goes into it. 16 goes into 336, so I split it up as 16 and 21. Square root of 16 is just 4 as a whole number. Then I check to see if there's any perfect squares that go into 21. There are not, so I would write it as just the square root of 21. So as my answer, I would write x equals 4 square roots of 21. Pause the video and see if you can do the got it question. Okay, in the got it question, it tells me the hypotenuse is 12, so I have to put that in the C spot. Then it tells me a leg has length 6, so you can put that in the A or B, and then use whatever letter you want for the other missing. So then I would simplify. I would get 36 plus x squared equals 144. I would subtract 36 and get 108. When I do the square root of 108 on my calculator, it is not a nice whole number, so I need to simplify. So I found that 36 went into 108. So square root of 36 is a nice whole number of 6, and then the square root of 3 will not break down any further, so my final answer would be 6 square roots of 3. Okay, next piece. Why don't you pause the video and see if you can do the next question, because it's just an application. Alright, on the next one, it's telling you that the size of a computer monitor is the length of its diagonal. So I went ahead and just drew a picture so that I could see what it's saying. It wants me to buy a 19-inch monitor, so that means my diagonal ends up being 19. Then it says the height is 11. It wants me to find the width. So what it's doing is giving me a leg and a hypotenuse so that I can find that other missing leg. So I went ahead and put it into the Pythagorean theorem. So 11 squared plus x squared equals 19 squared. I simplified. I got 121 for 11 squared and 361 for 19 squared. I subtracted 121 and got 240. And then this says that I can round to the nearest tenth, so I would just plug into my calculator the square root of 240 and round to the nearest tenth, so 15.5. So remember, when you're doing to the nearest tenth, you're looking at that number that is in the hundredth spot to tell you how to round in the tenth spot. Okay, next piece is the converse of the Pythagorean theorem. So the converse is saying that if you get numbers that fit the Pythagorean theorem, then your triangle has to be a right triangle. So if I get 2 legs squared and I add them and that equals the hypotenuse squared, then I know that I have a right triangle. So let's see a problem like that. So it says a triangle has side lengths 85, 84, and 13. Is it a right triangle? Notice it doesn't tell me which one is my legs, which ones are my hypotenuse. Automatically, the biggest number is always your hypotenuse. So I would just plug it into my Pythagorean theorem. My hypotenuse was 85, and then my 2 legs are 84. So then I square them all. I got 7,225 for 85 squared, 7,056 for 84 squared, and 169 for 13 squared. When I added this right-hand side, I got 7,225. So since I got them equaling each other, yes, it is a right triangle because when I did all that math, it worked out. Okay, so then on the next page here, it's still applying the same thing, but in order for you to see that your options to identify a triangle are either right, obtuse, or acute, this is showing you what it would look like if you had an obtuse or acute triangle. So this top one is saying if you're filling this Pythagorean theorem out and the square of your hypotenuse ends up being bigger than the sum of the squares of your legs, then my triangle is obtuse. If the square of my hypotenuse ends up being less than that sum of the square of the legs, then my triangle is acute. So the next two problems are just practicing that. So it says a triangle has side lengths 6, 11, and 14. Is it acute, obtuse, or right? So again, it doesn't tell me which one is which, so automatically the biggest one is the hypotenuse. So I like to write it exactly in this form, so I will put the hypotenuse first. So I will do 14 squared. I left a blank here because I don't know currently what it is. 6 squared, and then 11 squared. So then I found all of those squares. I got 196, 36, and 121. I added these two, and I got 157. So now I can fill in the blank. My hypotenuse squared is greater than my sum of my legs. So then by this top theorem, 8.3, that has to be obtuse. All right, pause the video and see if you can do the got it question. Okay, in the got it question, I had 7, 8, and 9. So 9 is my hypotenuse. So that means I filled it out looking like that. I'm squaring all of those numbers, so I got 81, 49, and 64. I added them, so then I filled in my blank. I got 81 is less than 113. So since my hypotenuse squared is less than the other legs, I know that my answer has to be acute. So today's lesson is just involving the Pythagorean theorem, excuse me, and then also the converse of that. Using the converse, you can identify if it's acute, obtuse, or right. All right, go ahead and start your assignment.